Endearment cadets, by the grace of Almighty, all of you are well, wherever you are, with your dearest and nearest one. Beloved cadets, I hope you stay home, stay safe, and stay fine. In the COVID-19 pandemic condition, Boishal Cadet College arranged online class. I welcome to all of you today's online class of class 9. Subject chemistry, chapter 3, name of the chapter structure of matter. Now dear cadets, enjoy the planet system where planets are revolving around the sun. Where planets are revolving around the sun, here particles are revolving around the nucleus. Here there is nucleus in the center of an atom and particles were in the outer space. Now, cadets, you think what will be the topic of this lecture today? The topic is electronic configuration of the element. By the end of this lesson, you will be able to learn electronic configuration, arrange electron in different orbit of an atom, apply and analyze the electronic configuration of an atom. Key points of this lecture: electron orbit, where electrons are revolving, orbital in the specific area where the finding of electron density is maximum, shell where the energy level where electrons are revolving, spectrum which are formed from the transition of electron from one energy level to another. At first, Ernst Rutherford developed the electronic configuration of the elements. According to his model, electrons are revolving around the nucleus in where there is no specific path. It has some limitations. According to Maxwell, if electrons are revolving in circular around the nucleus, but it has no specific circular path. So electrons gradually goes towards the center of atom and existence of the atom in the universe is destroyed. So there is a developed electronic model which is developed by Niels Bohr 1913. According to his model, there is a specific area around the nucleus where electrons are revolving. Here, there is the nucleus of an atom. First orbit where electrons are revolving, second orbit where electrons are revolving, third orbit where electrons are revolving. Electrons can transit from one energy level to another energy level by absorbing energy. Electron transit from lower energy level to higher energy level. By releasing energy, it goes back to its original state. This energy show spectra. Here, electrons are revolving around the nucleus as like as sun, where center nucleus is present, where in a specific area or orbit electrons are revolving. Here is the carbon atom, 6 electron, in the first orbit 2, in the second orbit 4. Electrons are revolving around the nucleus. Here, each orbit can exist or bear maximum number of electrons. If it is first, 2, if it is second, 8. By this way, electrons are revolving around the nucleus. Here first orbit 2 electron, second orbit 8 electron, third orbit 18 electron. First 2, second 8, third 18 electrons. By applying formula 2n square, electrons are arranged in different energy level, where n is the principal quantum number. If the value of n is on, in that case, this is the first orbit where 2 electrons can exist. If the value of n is 2, where second orbit 8 electrons can exist. If it is the value of n is 3, in that case, this is the third orbit where 18 electrons are present. For first orbit, first energy level, n is on. For second energy level, n is 2. For third energy level, n is 3. And for fourth energy level, n is 4. Here, different energy level. First energy level 2, second energy level 8, and third energy level 18 electrons can present according to 2n square formula. For helium, there are 2 electrons. These 2 electrons exist in the first energy level. Now, write down the electronic configuration of lithium, boron, magnesium, chlorine, and argon. Beloved cadets, in case of lithium, there are 3 electrons in the first orbit, 2, and next one in the second orbit. This is the first orbit, 2, and next one contain another electron. For case of boron, there are 5 electrons. In the first orbit, 2, and in the next orbit, 3 electrons are present. In case of magnesium, there are 12 electrons. In the first orbit, 2. In the second orbit, 8 electrons. And in the next orbit, 2 electrons are present. Here, there are 2 ways for writing electronic configuration of the atom. In case of dot, and also by using cross sign. Here, nitrogen 7 electron, first orbit 2, and next one 5. So in case of nitrogen, 7 electrons are present in the 2 shells. Now, calcium 20 electrons, sodium 11 electrons, oxygen 8 electrons, chlorine 17 electrons, silicon 14, and boron 5 electrons. Already we have discussed it. Now, draw the structure of that elements. Here, in case of sodium, 2,8,8,2. In case of sodium, 2,8,1. In case of calcium, 2,8,8,2. In case of oxygen, 2,6. In case of chlorine, 2,8,7. In case of silicon, 2,8,4. In case of boron, 2,3. These are the electronic configuration of the 6 elements. according to rules. Now, this electronic configuration you can also write by using cross sign. Here, in case of nitrogen, use dot or cross sign. This is the cross sign. Before that, we use dot. Here, oxygen, chlorine. Properties of element. From the electronic configuration of the element, we can easily understand the properties of the element. If there is one electron in its outermost energy level, it indicates its group. This is the element of group where group number is on. If there is one electron in outermost energy level, in case of S, here group number indicates its group number on. If there is 2 electron, it group number 2. So outermost energy levels electron for S element indicates its group number. If it is P, in that case, we add 10 with S and P orbitals electrons. If there is 7 electron for P orbital, by adding 10 for chlorine, last orbit contains 7 electron. So by adding 10, this is 17, it's group number 17. That means it is non-metals. It show reduction reaction. It participate reduction reaction. Also, it is oxidizing agent. It is non-metal and gaseous substance. In case of 2 electrons present in outermost energy level, here calcium 2 electron present. So it is metal. It takes part in oxidation reaction by releasing electron, but itself it is reducing agent. It is metal. It forms ionic bond. Here, from the electronic configuration of the elements, we can easily understand its property, its group number, and its period number. Higher energy level, outermost energy level indicates its period number. If energy level 1, 2, 3, in that case higher energy level 3, so it's period number 3. The outermost electrons present on atom in its electronic configuration indicates its group number. So by this way, we can easily understand the properties and position of the elements in the periodic table from its electronic configuration. Here, energy level, where electrons first exist or enter by applying the formula n plus L, where the value of n plus L is lower, electron first enter, if higher, electron gradually entering. For n is the principal quantum number for fourth shell, n is 1 for second shell, n is 2 for third shell, n is 3, and for fourth shell, n is 4. Here, L is the secondary quantum number. For s orbital, value of L is 0. For p orbital, value of L is 1. For d orbital, value of L is 2, and for f orbital 3. By combining the energy n plus L in the formula n plus L, so if the value is lower, electron first enter. If the value is higher, gradually electrons are entering in different orbital according to its energy. Electron at first enter in lower energy level and then gradually in higher energy level. We know energy defined by the summation of principal quantum number and secondary quantum number. Here for first, on s, its energy only on electron at first enter in this suborbital. Then 2s, 2p, 3s, 3p, 4s, 3d, then 4p. Here the value of 3d, 3 plus 2, 5. For 4s, 4 plus not, close to 4. So 4s is the lower energy containing orbital than that of the 3d. At first, electron enter in 4s. So on the basis of the energy of different orbital electrons are entering, here are some exceptional rule for electronic configuration of the elements. For chromium, there are 24 electrons. If you arrange 3d6 4s naught, but we know half filled and full filled orbitals are more stable. If you give 5 electrons in 3d and 1 electron in 4s, in that case 3d and 4s are half filled, because we know 3d orbital contain maximum 10 electron, s orbital contain 2 electron. So this is half filled. We know half filled orbitals are stable. For copper, 29 electron, if we arrange 3d9 4s on, but no 3d10 4s not. So 3d10, this is full fill orbital. This is full fill orbital. Okay, we know the electronic configuration of copper 3d10 4s naught. This is full fill orbital. In case of very small differences between the energies NF and N plus 1 into D, in that case electrons may enter in higher orbital. Here in case of lanthanum, 4f naught 3d on, 4f naught 3d on. This is the electronic configuration of lanthanum. By this way, electronic configuration of the elements are arranged in different orbital and suborbital. Dear cadets, draw the electronic configuration of the elements sodium, iron, and argon. The number of electrons of sodium 11, iron 26, and argon 18. Now, types of questions which may be set for from our lecture today. Knowledge-based question: what is orbit? What is transition? Where electrons are revolving around the nucleus is called orbit. Where transition, electron transit from one energy level to another energy level. Second type question, understanding level. Show the diagram of an atom. Already we discussed different types of diagrams of atoms: sodium, boron, lithium, etc. Now explain the energy of orbital. By applying formula N plus L, we can explain the energy of orbital. This is understanding level question. Application based question: there is an atom, electronic configuration of the outermost energy level is given. Now the question is set for draw a diagram of the electronic configuration of X. Here X is iron. There are two types of diagram. First one, the basis of energy, that means in shell, and next one in orbital. First one, N plus L, value of N plus L. On the basis of this fact, electron arranged 2, 8, 16. But in case of orbital based diagram, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So this diagram is based on energy level basis of orbital. We know 4s is less energy containing orbital than that of the 3d. For this reason, electron at first entered in 4s, then 3d. Next, higher order deep learning question, that means evaluation. Here this element. Now from that element, the question is set for evaluate the properties of the compound formed by the stream element.
Here there are different types of stem elements may be given: x n minus on d6 ns2, if it is y n minus on d5 ns on. There are different types of atoms or elements which may be set for. So now the solution of this question is, we need to first know the stem elements, then understand its electronic configuration, which it is metal or non-metal, then form a compound and evaluate its properties. This inorganic compound or organic compound, and what will be its properties. So it is inorganic compound, so its properties are on the basis of inorganic compounds. It form ionic bond, it dissolve in water. This type of properties are shown by this compound. So there is a home task for you. Two elements A and B are given. The question is set for what is orbit, energy level, configuration of A and B on the basis of electron, now form compound by the elements, and dissolve in which condition, evaluate. This type of question is set for from this stem. Dear cadets, you solve it and send in my inbox. Beloved cadets, if any query you asked me, in the next class I will solve it. Dear cadets, you know, this is very crucial time for COVID-19. It is pandemic condition, so you stay home, stay safe, stay fine with your family. Allah Hafiz.